Hello friends, good morning to all of you. I hope you all are well. Today we learn a chemistry which having a topic called as SN2 and SN1 reaction from the chapter of haloalkane and haloarine. If you are in the new in the channel, subscribe our channel to more info. See here we have the reaction which called to be SN2 reaction and which called to be bimolecular nucleophilic substitution reaction. Here rate of reaction is depend on both the reagent. At that time this reaction is called to be SN2 reaction. Full form of SN2 is substitution nucleophilic reaction. So how it happen? We see all the things. See here, the bimolecular nucleophilic substitution is a type of reaction mechanism that is common in organic chemistry. So for the haloalkane kind of compound, we just consider this kind of reaction to explain how the reaction is happen in simple haloalkane kind of compound. Here just we nucleophile we attach in the compound and we just remove from any particular kind of halogen in the haloalkane. So see here, the second one thing is explained to us. In the SN2 reaction, a strong nucleophile forms a new bond to sp3 hybridized carbon. Here we have basic compound is haloalkane which having sp3 kind of hybridization, you know that. So sp3 hybridized carbon atom via backside attack, while the leaving group detach from the reaction center in the concentrated fashion. Here we have example. Here we have sp3 kind of haloalkane which having 3 hydrogen and 1 halogen. Here any kind of nucleophile we just consider. So here we have nucleophile. This nucleophile is attack on this carbon from the back side. Here I explained this thing to you. So from the back side, either opposite side from the halogen element. At that time, this kind of thing is happen which called to be transition state. Here nucleophile try to attach with the carbon and leaving group is try to remove from this all this thing. And due to this kind of transition state, we have to get a final product which having nucleophile is attached from the opposite side of the halogen, and these 3 hydrogen which are present on the left hand side will move on the right hand side. First it come in this manner and then it come into right hand side. So this kind of transition state is just happen for the little bit time, and after the reaction is completion, leaving group is removed in form of particular kind of halogen atom, and instead of halogen nucleophile is attached, and this kind of product is called to be inversion, is called to be inverted product. Here one phenomena is happen which called to be inversion, means here the stereochemistry of the compound is just changed. Here the structure of compound is changed, the arrangement of hydrogen is changed. Here in the reagent there are the hydrogen are in the left hand side, in the product they are come into right hand side. So it just it moves or left to right due to attachment of this nucleophile which is highly concentrated, and it reacts with the carbon of particular haloalkane. It remove the halogen from here and it come instead of halogen, and it change the structure of the compound at the stereochemical aspect, and we get the final product as a particular nucleophile which having in particular alkyl group. Thank you. Friends, we have the next one example which is SN1 reaction. Either it called to be unimolecular nucleophilic substitution reaction. Here how it happens, we just explain with the mechanism of it. First we learn SN2 reaction and then after we have SN1, but here mechanism is also present. So SN1 reaction is basically known as unimolecular nucleophilic substitution reaction. Here the rate of reaction is depend on any one of the substrate from the reaction. So how it happened, we just see it. In the SN1 reaction is happen in 2 steps. First one thing is this reaction is happen in 2 steps, while in the SN2 reaction it happen in just 1 step reaction. So this is the basic difference in SN1 and SN2 reaction. First it makes carbocation, first it forms carbocation. Which kind of carbocation? Stable carbocation, and then nucleophile attack on stable carbocation. So first we form carbocation, and then after nucleophile is attack on this stable carbocation to form particular kind of product. So here rate of reaction is depend on concentration of any one of these substrate which is given in the reaction. So how reaction is happen? See here we have the example of tertiary haloalkane. We know that tertiary haloalkane is easily react with particular kind of nucleophile in SN1 manner. So how it happen? Here we have tertiary haloalkanes. You know that this is the tertiary carbon which having halogen and which having 3 methyl group are there, which is react with the nucleophile. But first nucleophile is not directly attack on this carbon. First we have a protic solvent like H2O, like alcohol, either acetic acid, whatever you consider. This protic solvent react with this tertiary haloalkane to break the bond in between carbon and halogen to form stable carbocation. So first we use the protic solvent. You know that protic solvent means a solvent which having tendency to donate H plus of the particular kind of substrate. So either you consider H2O, here I mention H2O, okay, I just mention H plus. H plus means the proton which coming from either H2O, either alcohol, either acetic acid. So this proton is try to make a different kind of thing here, try to break the bond in between C and X. So first we form carbocation, but here in the reaction form I just write directly product. Okay, so this nucleophile is attached on this carbon to form particular product. Leaving group is X minus here. So I just mentioned these are the 3 protic solvent which are mentioned in our textbook also. How the reaction is happen, mechanism will show all these things. So step 1 is called to be formation of carbocation. In this step we just form carbocation. First we have tertiary haloalkane, and this tertiary haloalkane break the bond in between carbon and halogen in the presence of protic solvent like H2O, alcohol, either acetic acid. I repeat all the 3 names one by one: H2O, alcohol, acetic acid. Remember that thing. Kind of MCQs also come, which is the slow step, and first it form carbocation here. This is the stable carbocation. Why stable carbocation? You know that there are 3 methyl group are surrounded this C plus. You know that the methyl group are electron donating group, which make this carbocation very stable, and leaving group is X minus here which having 2 electron also. So first we make stable carbocation. In the next one step is the nucleophilic substitution reaction, means nucleophile is attack on this stable carbocation. So this nucleophile is attack on the stable carbocation, which is the fast step. You know that the slow step is the red determining step. So this reaction is called to be unimolecular, either SN1 reaction. Rate of reaction is depend on the step 1, so it called to be SN1 reaction. Okay, so in the next one step, means the second one step, this is the carbocation which attract towards the nucleophile. Nucleophile is attack on this stable carbocation, which is the first step, and will form up kind of particular product as having nucleophile. So this is SN1 reaction. Friends, let's see the reactivity order of SN1 and SN2 reaction. I just mentioned all different kind of compound which we make from the haloalkane. Either we have methyl group, either we have primary, either secondary, either tertiary alkyl group. Any one of alkyl group you consider. So just I mentioned to stability and reaction rate, either reactivity order, whatever you say. So if we have this methyl group, either it called to be methyl carbocation, which shows SN2 reaction easily. But when we move on the primary carbocation, secondary carbocation, either from the tertiary carbocation, the SN1 reaction will be easy on left to right manner. So see here this is the low stability, but SN1 reaction is easily happen on the methyl carbocation. When we move on methyl to primary, primary to secondary, secondary to tertiary, the stability is gradually increased, and at that time SN1 reaction is easily happen. Means when we move on the left to right side, SN1 reaction will be easy manner, and when we move on the right to left side, either means the tertiary to methyl group, SN2 reaction will be easy. So here this is the easily we just explain the reactivity order of SN1 and SN2 reaction. How SN1 is possible, how SN2 is possible. You learn easy way from this kind of things. So I hope this video is like you, this video is helpful to you. If this video is helpful to you, please subscribe our channel and share to all your friends and students. Thank you very much. We'll meet with the next video. Please keep watching our channel. Thank you.